So let's read this question. If k1 is equal to tan of 27 theta minus tan theta and k2 is equal to sin theta upon cos 3 theta plus sin 3 theta upon cos of 9 theta plus sin of 9 theta upon cos of 27 theta, then k1 upon k2 is equal to what? अब हम देख सकते हैं कि जो प्रॉब्लम है ये थोड़ा सा कॉम्प्लेक्स सा दिख रहा है क्योंकि K2 is about you need to like clump this up so as to take a good ratio. So instead of clumping things up, try to expand them. Expansion is really easier than compression of things. So what I'll do is I'll expand this K1 so as to match this some form in K2. All right. So before that, I'll list a key concept. Key concept would be trigonometric identities. So basically, I'm going to be using trigonometric identities to solve this problem. And the first trigonometric identity that I'll use is sine of 3 theta is equal to 3 sine theta minus 4 sine cube theta. Second is cos of 3 theta is equal to 4 cos cube theta, 3 cos theta. The third identity that I'm going to use is sine square theta plus cos square theta is equal to 1. Fourth identity that I'm going to need is tan of A would be sin A upon cos A. Now what I'm going to use is I'm going to state a special result which would be very instrumental in solving this problem and would only be required to solve these kinds of problems. I'm going to use these above identities to derive that special result. So this is a special result. So the special result is tan of 3 theta, and this tan of 3 theta we all know would be sin 3 theta upon cos 3 theta. Now this would be 3 sin theta minus 4 sin cube theta upon cos of 4 cos cube theta minus 3 cos theta. Now I can write these as sin theta in common times 3 minus 4 sin square theta upon cos theta in common times 4 cos square theta minus 3. Now I'll be writing this sin square theta as 1 minus cos square theta. So this becomes sin theta times 3 minus 4 times of 1 minus cos square theta. And I'll leave the denominator as it is, as cos theta times 4 cos square theta minus 3. The idea is to obtain something which gives me a term in tan theta and some other different term. So this becomes sin theta times of 3 minus 4 plus 4 cos square theta upon cos theta times 4 cos square theta minus 3. This is sin theta times 4 cos square theta minus 1 upon cos theta times 4 cos square theta minus 3. Now, so as to make one term same in both denominator and numerator, I'll split this numerator as this fraction would become sin theta would remain as it is, and I'll write this in bracket term as 4 cos square theta minus 3 plus 2 sin theta. Of course, and this would whole be divided by cos theta times 4 cos square theta minus 3. So hence this will become sin theta upon cos theta, because I'll split this up as sin theta times 4 cos square theta minus 3 upon cos theta times 4 cos square theta minus 3, and of course because these both terms are equal, we'll cancel them off, plus 2 times sin theta would remain same. and this denominator term was just the expansion form of cos 3 theta. So this is basically written as cos 3 theta, and this entire above fraction would become sin theta upon cos theta plus 2 sin theta upon cos of 3 theta, and hence this is basically written as tan theta plus 2 sin theta upon cos of 3 theta. So this would be the value of tan of 3 theta. Now how is this gonna be useful in the problem? We'll explore this in the next step. Given was given to be tan of 27 theta minus tan of theta. Now note that I am interested in splitting this tan of 27 theta. So I'll write this tan of 27 theta would be equal to, as I said, that tan of 3 theta is equal to 2 sin theta upon cos 3 theta. So using the similar rule, I'll have tan of 3 times of 9 theta would be equal to tan of 3 times of 9 theta. And of course, we know that tan of 3 theta is equal to tan theta, which in this case would become tan of 9 theta plus sine of theta upon cos of 3 theta, which will be 27 theta. And again, this tan of 9 theta can be rewritten as tan of 9 theta is equal to tan of 3 times of 3 theta, which is again tan of 3 theta plus sine 3 theta upon cos of 9 theta. And I'll write this tan 3 theta as tan of 3 theta will be tan theta plus sine theta, rather twice of these things upon cos of 3 theta. And replacing tan theta, I'll just number up these equations. This would be 1, this is 2, and this is 3. So what I'll do is I'll replace 3 in 2, replacing 3 in 2. So I have to obtain tan of 9 theta would be equal to tan theta plus sine theta, 2 sine theta upon cos 3 theta plus 2 sine 3 theta upon cos of 9 theta. I'll number this up as 4. Place 4 in 1. So what I'm doing is replacing 4 in 1. So the equation 1, which consists of tan 9 theta plus 2 times sin 9 theta upon cos 27 theta, will become tan of 27 theta is equal to tan theta plus twice sin theta upon cos 3 theta plus twice sin 3 theta upon cos 9 theta plus twice sin 9 theta upon cos of 27 theta. And the k1 was given to be tan of 27 theta minus tan theta. Hence our k1 would become, I'll just subtract this tan theta from this above equation and I'll obtain twice of, because 2 will be common in all the terms. This would be sin theta upon cos 3 theta plus sin 3 theta upon cos of 9 theta plus sine of 9 theta upon cos of 27 theta. Hence, the thing that we had to evaluate upon K2, which is question mark, and the K2 was given to be K2 is equal to sine theta upon cos 3 theta plus cos theta, rather sine 3 theta upon cos of 9 theta plus sine of 9 theta upon cos of 27 theta. And if we divide this k1 by k2, we observe that this bracket term is same in both the cases, and hence we'll cancel them off, and we'll obtain the final answer to be 1 upon k2 would be 2. This is our final answer. I hope you understood it well and best of luck.